Hello everyone. In this video we are going to discuss about algorithm for short term hydrothermal scheduling using gamma and lambda iterations. Algorithm for short term hydrothermal scheduling using gamma and lambda iterations. In this algorithm, our first step 1, is to choose epsilon 1, which is nothing but the tolerance for power mismatch with respect to thermal power generation, and epsilon 2, which is the tolerance for water discharge. We are going to define the tolerance for both power mismatch and tolerance for water discharge, and they are respectively epsilon 1 and epsilon 2. We are making sure the tolerance first step. Okay, later in step 2, select the initial values of gamma and lambda k. This is the step 2. We are initializing the value of gamma and lambda. Okay, we are assuming initially all generations are 0. Assuming all the generations are 0, we have initialized the value of gamma and lambda. Other than assuming initial generation value 0, you can also choose some arbitrary values other than 0 if you want. Okay, and in step 3, we are going to define the value of k. Step 3, the value of k is 1. K varies from 1 to capital N, so we are defining it as 1 in the first stage. K is equal to 1 for the first time interval. This is our first time interval, you can mark it. This is our step 3. Okay, after that, step 4, we need to calculate thermal power generation PGTK using the coordination equation. And we all know what is the coordination equation. In the previous video we discussed about this. HK df PGTK divided by dPGTK plus lambda k dou P loss by dou pgtk is equal to lambda. From this we are going to find the value of pgtk. Okay, we are continuing how we are going to find the value of pgtk in this. If you go back to the previous video, you can find equation number 6, which is our arbitrary equations from a Lagrangian function. From there we have deriving this. And for the above equation, for this same equation, I am going to put the value of df pgtk by dpgtk and dou p loss by dou pgtk values. We are substituting these two values here. First term is hk. df pgtk by dpgtk can be replaced by bt plus 2 times ct pgtk plus lambda k. Dou p loss by dou pgtk can be replaced by 2 times btt pgtk plus 2 bth pghk. That will be equal to lambda k. Okay, after substituting, now we got this one, and from these we are going to take pgtk on the LHS and remaining terms on the RHS. On redefining, we'll get pgtk as lambda k minus hkbt minus 2 times lambda k bth pgh whole divided by 2 times hk ct plus 2 times lambda k btt. From this equation we are going to find the value of pgtk. This is our step 4. Next is our step 5. In step 5 we are going to calculate pghk using coordination equation. From the previous video you can go through equation number 7 will be our coordination equation for pghk. From equation 7 we can take a gamma hk dq naught k pghk divided by dpghk plus lambda k dou p loss by dou pghk will be equal to lambda k. This equation, from this equation we are going to substitute the value of dou q naught k pghk by dpghk and dou p loss by dou pghk. We are going to substitute these values and we'll be having gamma hk. The value of dq naught k pghk by dpghk is bh plus lambda k. Dou p loss by dou pghk can be replaced by 2 bhh pghk plus 2 bth pgtk is equal to lambda k. And from this equation we are going to equate for pghk. Therefore pgh k is equal to lambda k minus gamma hk bh minus 2 times lambda k bth pgtk whole divided by the coefficients of pghk is 2 times lambda k bhh. The step 5 we got the value of pghk, and in step 4 we got the value of pgtk. Okay. In the next step, step number 6, we are going to calculate delta pk, change in load. Okay, delta pk is pdk plus ploss k minus pgtk minus pghk. Change in power is calculated in this step. Okay, this gives the power deviation. What is the amount of power that has been deviated from the actual or the on course power. Okay, if in this if the magnitude of delta pk is greater than epsilon 1, then let lambda k is equal to lambda k plus del lambda k. Okay, if the deviated power is more than the tolerance, epsilon 1 is the power tolerance that we choose. If it is more than the epsilon 1, we are going to increase the value of lambda by small value delta lambda k. Okay, we are going to choose positive value of lambda k if delta pk is greater than 0 and negative value if delta pk is less than 0. Okay, to choose the value of lambda, we are having this procedure. If the delta pk change in power is greater than 0, we are going to make it as a negative value for lambda, positive value for lambda, and negative value if delta pk is less than 0. Okay, after this step, we go back to step 4. Okay, in step 4 we are going to increase the value of k. Remember that. Sorry, in step 4 we are going to calculate the value of pgtk. After that again we come back to calculate the value of pghk. Later, change in deviation. Okay, next is step 6. Sorry, step 7. If delta pk is less than or equal to epsilon 1, if delta pk is less than or equal to epsilon 1, calculate q naught k using q naught k is equal to ah plus bh pgh, and q naught k is equal to ah plus bh pgh plus ch pgh square. This q naught is for below limits. This is for above limits. We have set the value of q naught. If the value of q naught is below the prescribed value, we are going to choose this equation. If it is above the prescribed value, we are going to choose this equation. Okay, this is our step 7. And in step 8, we'll check if k is equal to n, which means are we in the last interval or not. We are going to verify whether we are in the last interval or not. Okay, if not, if we are not in the last interval, then let k is equal to k plus 1. We are increasing the value of k by one number. And go to step 4, where we are going to calculate a PGT and in the next step PGH. Okay, this is our step 8. After step 8, in step 9, we are going to check once q naught k has been computed for k is equal to 1 to n. We'll once again verify for the value of q naught k whether the value of q naught k has been computed for k is equal to 1 to n or not in this step. And we'll check if delta q is equal to magnitude summation of k is equal to 1 to capital N q naught k hk minus q total is less than or equal to epsilon 2. Okay, epsilon 2 is the tolerance value for q naught. And here we'll check whether the value of q naught is delta q naught is 0 or not. This should be equal to 0 as per our calculations, where q naught is the total value available, total water available for discharge for hydropower plants. Q total is the total water available for discharge in the hydropower plant. Step 10, we'll check whether we need to stop this loop or not. Checking if it is S, stop. If it is less than epsilon naught, we are going to stop this algorithm. If not, step 11, if magnitude delta q is greater than epsilon 2, let gamma is equal to gamma plus delta gamma. Okay, if delta q is greater than epsilon, we are going to increase the gamma value by small value delta gamma. That is, delta gamma is positive if delta q is positive. Delta gamma is positive if delta q is positive. Okay, and delta gamma is negative if delta q is negative. You can see step 11, we are going to check whether delta q is greater than epsilon or not. And last step, step 12, we'll go to step 4. If delta q is greater than epsilon 2, we'll move back to step 4 with these two conditions. Okay, we continue the loop iterations for gamma and lambda until the value of delta p and delta q have converged. Hope you people getting my point. Converged meaning, okay, till the value of delta q and delta p, the value of delta q and delta p. Here we are having delta p, step 7 and step 9. Until the step 7 and step 9 are proved, we are going to repeat this process, okay, this loop until this is converged. Okay, this is all about algorithm for short term hydrothermal scheduling using gamma and lambda iterations. We'll catch up with our next video on flow chart for the same. Okay, thank you.